Okay, good afternoon, class. So today we're looking at Trigonometry chapter 5. We're looking at the examples for exercise 6. And we're looking at proving identities using... No. We're looking at solving equations and determining the general solution. But we have dealt with general solution before already, not so? We've done with dealt with general solution where the angle is a compound angle or the angle was a double angle. You just refresh your memory. If you had cos of theta is equal to sine of 2 theta, if that was the question, what do? You get the cos is the same, so it will become cos theta is equal to sine, if that was 2 theta minus 10 for argument's sake. Okay? That could be written as cos 90 minus 2 theta minus 10. Why? So that we can drop the causes and so on. You guys remember that? Right, 2 people, the others, I don't know. But there you can see it's a compound angle. If I had given you sine of 2 theta is equal to 50, these are what? A double angle. Okay, so nothing that yet in you to the general solution part. Okay, but you'll see now that they will give you something that you need, probably an expansion of the general solution to reduce, so that we can land up with this. Okay, and simplify from there, and we are familiar with that. So here we are told that in grade 11 we have learned how to solve trigonometric equations by finding the general solution and using it to find specific solutions in a given interval. In grade 12, double and compound angles appear in trigonometric equations. You can solve these by substituting into the double angle and compound angle formulae into the equation. Always find the general solution first and solve for specific solutions in a given interval only when required. Okay, so let's look at the first example and the solving equations that ends with 1 ratio. So this is example 1, and example 1 is on page. Example 1 is on page 103. Okay. So we got solve for x if 3 cos 2x minus 25 plus 1 is equal to 0. And x is greater than or equal to negative 360 or less than or equal to 360. As they said, we're going to find the general solution first. Not so. This is the examples for exercise 6. And exercise 6 is on page 105. Okay. So where do we start? 3 cos x minus 25 plus 2 is equal to 0. A grade 11 learner could solve this. Or you should have been able to solve it in grade 11. So let's do it together quickly. Yes, not everybody at once. Take over the 2. And then divide by 3. It's going to be negative 2 over 3. Now what do I do? Okay, now let's do it as if I'm the only one here. I'll take my reference angle. So it's going to be x minus 25 is equal to r cos of 2 over 3. What do you notice? I've dropped the negative sign. Not so. So what I do, I put in the calculator r cos, shift cos, r cos, or cos to the negative 1. R cos of 2/3 gives me 48,12. So your reference angle of x minus 25 is 48,12 degrees. Oh, sorry, 19. 48,19 degrees. That's now my reference angle. What question comes to mind? In which quadrant is cos negative? So which quadrant is cos negative? 2 and 3. So how do you get into quadrant 2? So it's going to be x minus 25 is equal to 180 minus 48,19 plus k times 360. Not so? So let's put that in the calculator. I'm going to bring that 25 also over the equal sign. So we say x is equal to 180 minus that angle of 48,19 plus 25. With the angle of plus 25 is 48,19. Excuse me, 156,81. 156,81 plus k times 360. So that's the general solution for branch 2. Yeah? Let's look at quadrant 3. How do you get into quadrant 3? X minus 25 is equal to 180 plus 48,19 plus k times 360. So x works out to be 180 plus 48,19 plus 25. So 253,19 plus k times 60. Where k is an element of integers. But remember, there's a restricted domain here, not so. A restricted domain from negative 360 to 360. So what do I say? X is an element of. And now we need to test. If I'm going to put a 0, since that value is already on the calculator, no? If I'm going to put a 0 through here, where I see k, then what are we going to get? 253,19. What will happen if I put a 1 here by k? Then it's going to be outside this 360 degree range, not so? So what do? I'm going to put a negative 1. So it's going to be minus 1 times 360 gives you an answer of negative 106,81. What do you think if I put a minus 2 here? It will be lower than negative 360. Can you see that, people? If I take an answer minus 360, give me an answer of negative 466,81. As I said, it's outside that range. You guys understand? Let's check this one here. If I put 0 through here, what am I going to get? 156,81. Not so. What if I put 2 in here? It will be 360 plus an angle, definitely out of the range. So what do I do now? Negative 1. So we put 156.81 plus negative 1 times 360. Is we negative 203. Is that in that range? Yes. Negative 203,19. What will happen if I put negative 2 in here? Let's go, negative 2 will be negative 563. Which means you say it is again? Outside. So do I write that one down? No. So I just, there is a solution. Alright. Is there any confusion here? Okay, as I said, you should have been able to solve this in grade 11 or 12 with the information that you have. Right, let's look at example 2. Sorry? Example 2 is on page 104. So again, we're looking at general solution, work example 2. In this example, use double angles. Okay, so what do you notice here? It says solve for x if 4 sine x cos x is equal to the square root of 3 and x is greater than or equal to negative 180 but less than or equal to 360. What do you see here? What does this remind us of? Cos x sine x, so sine x cos x. If there's a 2, then that is equal to sine 2. So what do we have here? A 4. So in other words, this could be written as 2 times 2 sine x cos x. Not so? Is alpha alpha, so that will be alpha. Okay. And this is equal to the square root of. But what did we say? What is sine x cos x equal to? 2 sine x cos x. Sine 2x. Not so? So in other words, it's going to be 2 sine 2x is equal to the square root of 3. Now what? Divided by 2 both sides. That cancels. So this will give you sine 2x is equal to the root of 3 over 2. This is a double angle. So what do we do now? Work out our reference angle. Not so. But this is a special angle. The value of 60. Now say for instance you didn't know that. We go arc sine of 3 over 2. Root 3 over 2. Whoops. Is that 60? Okay, so what do we say? Our reference 2x is equal to 60 degrees. Now what do we ask ourselves? Which quadrant is? Sine positive. So we go all stations to claim. Which quadrants are sine positive? 1 and 2. So let's go to quadrant 1. Are you getting quadrant 1? 2x is equal to 60 plus k times 360. I divide it out by 2, so x is equal to 30 plus k times 1. Okay? Are we going to quadrant 2? 180 minus. So it's going to be 2x is equal to, okay, for those of you who are confused, you get the quadrant 2 is 180 minus, quadrant 3 is 180 plus, quadrant 4, 360 minus. If we have a choice, that's what we do. Huh? Alright, so then this would be 180 minus 60 plus k times 360. Again, we do not divide here by 2. And earlier on, we did not take that angle of 25 over the equal sign until we took it to its quadrants. Okay. Let's tidy this up a bit. So 180 minus 60 is 120. 120 divided by 2 is 60. Plus k times, and 360 divided by 2 is 180. Where k is in the element of integers. But have you answered the question? What's the question? They gave us a restricted domain here. Not so. So what do? You start with, so we say x is an element of, you start listing. You start with k is 0. Not so. If k is 0, then what is this answer? 30. If k is 1, so it's 180 plus 30. 220, 210. If k is 2, it's 360. 360 plus 30? 390, which is outside. So if 2 doesn't work, am I going to try 3 and 4 and 5? Not yes. No. Because a 1 doesn't work, or 2 doesn't work, 3 won't work, 4 won't work, and so on. So the number is getting bigger. So now we try negative 1. Let's put negative 1 in here. So it's 30 plus negative 180, which is negative 150, which is inside. Not so. If I put negative 2 in, I get negative 360, which is negative 330, which is again outside. Am I going to try negative 3? No. Okay. It's gone this side. So that is depleted. That's used up now. Let's go here. If we put 0 in here, what do we get? 60. Put 1 in? 240, which is inside. Put 2 in? 360 plus 60 is 420, which is outside. Put minus 1 in. 60 minus 180. You get the 120. Put minus 2 is negative 360 plus 6 is negative 300, which is again outside. So do I write that down? No. There's your answer. Some like this is probably worth a few marks, a good couple of marks. Okay. I would say probably like 4 or 5 marks. Or sometimes more. I think 4 or 5 is 4 is fair for this question. What I will do is I just will reduce this domain here. Okay? So that there's less values, so less work to do. Okay. Do you have any confusion there? No? Let's look at another one. This is example 3. And example 3 is on page 210. Same page, okay. This example uses compound. Okay. Give the general solution. So here's no restricted domain. When I get to that k is an element of integers, I stop. Okay. Give the general solution of the equation sine 3x cos x minus cos 3x sine x equal to 0, 4. People, if 3x was alpha and cos was beta, then this would have read sine alpha cos beta minus cos alpha sine beta. Which rule is that? Sine rule. Plus or minus? Minus. So that would be sine alpha minus beta. Not so. And what's the alpha angle here? 3x. And here? X. So it's going to be 3x minus x. You guys understand? So let's go. So we said it's going to be your sine identity. Sine alpha, which is 3x minus x, is equal to 0, 4. Now what? What is 3x minus x? Nice, you guys are good. 0, 4. Now what do we ask ourselves? The same thing we ask ourselves all the time is, in which quadrant is sine positive? So in which quadrant is sine positive? 1 and 2. How do we get into quadrant 1? So it's going to be, by reference, 2x is equal to arc sine. We normally ask that after we do this. Right? Why do you guys open some windows? You guys still don't want to open windows. Yeah. Don't you guys like fresh air? Okay. Sine of 0, arc sine of 0.4. Here we go. Arc sine of 0.4. 23, 58. So 23, 58 degrees. And now we ask ourselves in which quadrant is sine positive. Which is sine positive? 1 and 2. Let's go to quadrant 1. How do we get into quadrant 1? So it will be 2x is equal to 23, 58 plus k times 360. So what do? We divide by 2, not so. So x equal to 23, 58 divided by 2 gives me 11,79 plus k times 1. Okay. So what do we do now? Which quadrant is sine positive in the second branch? 180 minus. Sorry about that. So what do we get? 2x is equal to 180 minus 23,58 plus k times 360. So it's 180 minus 23,58 divided by 2 gives us 78,21. Plus k times, where k is an element of. But I think that once for both is suffice. Okay, you don't have to put it by each branch. Do we stop there or carry on? Stop. Why don't we carry on? There's no restricted domain. Do you guys understand? You just can't understand why is the sum so easy. No? I also can't understand why. Plus you grade 12. No? They always made us scared. Grade 12 is difficult. No? Okay, again talking to myself. Example 4 is on page 105, correct? That's the only thing you can give me the page number. But okay. People, give the generals again, it is no restricted domain. The general solution of the equation 2x, cos 2x over cos 50 minus sin 2x over cos 40 equals 0. So where do we stop? Wow, she says. Huh? Changing cos to 40. Oh, this one. Well, what do you say? I don't want to say your middle name. I only know your middle name. Can I say it? No. Oh, okay. Leah. What did you say, Michael? Change cos 2x to what? One of the three. That's going to make the sum more complex. Okay. LCM. Nice! Alright, so what's your LCM here? LCM is cos 50, cos 40. Nice. So this will be multiplied by cos 40. And it in the numerator. So cos 2x, cos 40 minus. This must be multiplied by cos 50. So it's going to be sin 2x, sin cos 50 equals 0. Because 1 multiplied by cos 40 cos 50, 0 multiplied by cos 40 cos 50 will give you 0. So hang on. Cos sin. Sin. So that's a cos. So what must I do? Change it to sine this. And now we're going to change this to a sine. 90 minus. Not so. That will simply be cos 20 cos 40 minus sine 2x times sine of 40. For those of you who are a bit lost, that would simply be cos of 90 minus 40. And 90 minus cos changes to sine. So it's going to be sine. Hence that. Do I have to show that? No. That's equal to 0. Cos, sine. Which rule? Cos, yes. So let's go. Cos. Alpha, beta. Plus or minus? Plus. It's the opposite side. So now. Okay. Yes, as the clock line, eh? That's 0. Not so. Now what? Now when we get 1 minus 1 and 0, what do? We take it to the graph. So now we look at the cos graph. And there's the cos graph. So where's cos 0? At 90 and not 180, nice. 270. Remember 0, 90, 180? Is that minus 1, 270 and 360. So where's cos 0? Where's cos 0? At 90 and 270. So you can write this as 2x plus 40 equals 90 plus k times 360. So I take a 90 over the equal sign. Comes 90 minus 40, which is what?
50.
Divided by 2, 25. Is these questions I'm asking yourself too easy for you to? Yes, okay, now it makes sense. Okay, because I'm going a bit crazy here. I'm thinking you guys are writing a final exam in a couple of days' time. I don't know. Right. So that's the one branch. And on the other end, we got 2x plus 40 equals. That's going to be 270 plus k times 360. Take that over the equal sign. 270 minus 40 is 230. Divided by 2 is 115 degrees plus k times 180. Where k is an element of integers. Now somebody could say, not here in this class, somewhere else, could say, but now we can see from this point, we can see that this solution happens every 180 degrees. Not so. So instead of drawing two branches, I can just write it as one. As 2x plus 40 equals 90 plus k times, because it's happening every 180 degrees, that is k times 180. With that, I'm already picking up the solution with k is 1. Okay, take 40 over, becomes 2x is equal to 50 plus k times 180, and then divided by 2, which is 25 plus k times 90. Where k is an element of integers. Both get you full marks. Okay. And that basically brings us to the end of exercise 6, which is on page 105. And of course, the full lessons can be found in the description box below. Okay.